Uh, Very good morning to all of you. This is Surajit Dey, Assistant Professor in the Department of Data Science from India Institute of Technology. Today I'm going to discuss on the basic preliminary concepts of machine learning. So these are the topics that I'm going to discuss on today. The first of all, I will discuss what is machine learning. Then I will discuss types of machine learning, application of machine learning, challenges in machine learning, and at last, tools and libraries that we use for implementing the machine learning. So first of all, what is machine learning? Machine learning. Before I describe this topic, I want to uh, describe the topic of artificial intelligence because the artificial intelligence is very important before you jump into the machine learning. Now, what is artificial intelligence? Artificial intelligence is something which mimics the human brain, like that. Our human brain, in that way, the way our human brain works, the objective is to develop a model so that it can work with the similar behavior as our brain works. The way our human brain, our brain interpret the data, sense the data, takes the decisions based on the data. In the same way, the machine can interpret the data, understands the data, and take the decision based on that interpretations. That is the objective of artificial intelligence. If you come to the machine learning is a subset of artificial intelligence that enables system to learn and improve from experience without being explicitly programmed. So means there will be no supervisions, there will be no programming. So what we will have we, at all that the data set, the data that something that we will have in our hand. And based on the data set, the machines will be trained. Now, after the training, the machine learns by itself from this data. And now, if I give some sample input, then it can sense what actually it is. And this is the machine learning. Right? This is the machine learning. So here, focuses on developing the algorithms that can identify the patterns and make decisions. This is very important for the machine learning. Now, if I compare the traditional programming and machine learning, then you can see that for the traditional programming, so we are applying the rules in the form of the syntax, rules and syntax based on your data, based on your inputs, and produces an output. That is what we have seen in that case of traditional programming. If it come, for the machine learning, now what we have the data and we know the output. So based on this output and data, what we'll get the rules, we get the interpretations. So this is the difference between the traditional programming and machine learning. So machine learning finds patterns from the data instead of being given the fixed rules. So it learns by its own way based on your data sets. Right? Now the types of machine learning. So we have the different types of machine learning. We can have the supervised learning, we can have the unsupervised learning, and as well as we can have the reinforcement learning. Now these are the three types of learning method of for the machine learning. Now, for the supervised learning, what we have the label data. We should have the label data. Like this is one, this is zero. Like this is true, this is false, like that. And these are the classifications, the regressions of the two types of supervised learning. Classification means you can classify your data, whether true or false, zero or one, like that. The regressions means the continuous one. What will be the stock value particular for a particular stock in our census share market? Now, in the case of unsupervised learning, we don't have any labeled data. There will be all the unlabeled data. So, in that case, the machine finds the interpretations based on this data that we can do on its own. Clustering and associations, these are the two examples of the unsupervised learning. Now come to the reinforcement learning. Then the reinforcement learning, the learning via rewards and penalties. If you take the good decisions, you will be awarded. If you take the bad decisions or wrong decisions, you will be penalized. So this is the simple rules for the reinforcement learning. Now, applications for machine learning, these are the areas where you can apply your machine learning models like image and speech recognitions, recommendation systems, fraud detections, autonomous vehicles, natural language processing. Like, if, for example, the recommendation systems, we have seen that, for after log into the Netflix movies, some movies will be recommended by itself, by the system, based on your choice. So when you are logging into the Flipkart or Amazon's, some, the likely products will be shown in front of us. So these are called the recommendation system. And these are the recommended by the system itself based on our past behavior. Like in the autonomous vehicles, the vehicles will run without the human beings. The vehicles can take its own decisions, right? When to stop, when to start, when to turn left, when to turn right, like that. Like in the natural language processing, we are interpreting the language so that it can transfer into the voice, like Alexa, Siri. This is the example of a natural language. Now, if you go into the supervised learning, so in the supervised learning, there will be some supervisions. Right? You have to train your model. So after training the model learns itself. Right? Now the model can starting, to take its own decisions. Right? Like, email spam detections, whether the email wish to you will be grouped into the normal mail or it will go into the spam folder. The house price predictions. These are the example of supervised learning and linear regressions, decisions, tree, SVM, support vector machines. These are the examples of supervised learning algorithm. Now come to the unsupervised learning. In the unsupervised learning, no supervisions will be there. The machines, the data will be provided to the machine or model itself. The model has to learn by its own way. The model has to find the patterns or structure of the data, right? Like, customer segmentations, market basket ratios. The customers, like, for example, the customer segmentations, you have to classify your customers for generating the offer, the customized offer to the individual. So for which customer you have to give the more the reductions, the more facility to your customers. And the cadence clustering, principal component analysis, PCA, these are the examples of unsupervised learning. Then the reinforcement learning. As I said, the reinforcement learning, what you have to learn the optimal actions through trial and error basis. You do one thing, if it is okay, then proceed to the next step. If it is wrong, then correct yourself. So this is the trial and error method until you reach your optimal solution. Like training an AI to play games or drive a car. Okay? You have to redo your steps until you find the desired outcome. These are the examples. So these are the key machine learning workflow. So this is the way actually machine learning works. First, you have to define the problem that you are going to solve. Then the second step, collect and prepare data from different sources, right? Choose the particular model depending on your problem nature. Then train the model. Then evaluate and tune your parameters so that you can reach your optimized solutions. Right? Then you deploy and monitor your model, how it will be work. Just monitor. So these are the challenges in machine learning, the data quality and quantity that you should have the sufficient number of data so that the machine learns particularly right and efficiently, right? And the data should be in high quality. No missing value should be there. No noise should be there. So these are the things that you should do before applying any model on your particular data sets. Now, overfitting and underfitting means sometimes your machine works well in the training period but fails in the testing period, and the vice versa as well. Works well in the testing period, fails in the training period. Right. So these are the things happens because of your noisy data sets. So you have to eliminate those things from the data sheets, and then you should apply the model on your data sheets. The bias and fairness should have, the error, the bias should be minimized. Right? Bias means what? Bias means the differences between the actual output and the desired output. And everything should be fair, right, in your data set. The last term is scalability, means you have, as the data scales up, as the days go past, the data will be increased. So what you have to do is the model fits in that scaling data. You should have capable to catch up those, the increased volume of data, right? So these are the tools and libraries used. So basically, we use the Python programming as well as the R programming, and these are the libraries that are going to use, like SCI, Scikit-learn, TensorFlow, PyTorch, Keras, XGBoost. Like SCI, Scikit-learn, we are using Matplotlib, like some simple pandas libraries. So some simple libraries are there which works on this library. The TensorFlow for implementing the artificial neural network, PyTorch, Keras. So these are all the open sources libraries that are used for a specific job, right? They for the XGBoost, for the gradient boosting algorithm, right? You have to use. There is the numerous, applications can be done using that different libraries. So in summary, what we can say, the machine learning enables computers to learn from the data without any human intervention. And we have three types of machine learning: supervised learning and unsupervised learning and reinforcement learning. We have the broad applications that is the different industry to use the machine learning, and still machine learning evolving with the challenges and opportunities to fit itself in optimized positions. So that's all from my side. Thank you. Thank you very much.